I want to talk really quickly about two things. One is this irrigation scheduling that you can do on your phone or web browser. So basically, soil is we can use the soil as a reservoir to store water and nutrients for use by the crop. So when we do irrigation scheduling, it's really important for us to know how big that reservoir is, or how much water that soil can hold, and then how fast the water is being depleted from that reservoir. And so the size of the soil reservoir depends on two things. One is the water holding capacity of the soil. So the water holding capacity of a sandy soil is small compared to the water holding capacity of a silt loam soil. So the water holding capacity of the soil and the root zone depth, or how much soil the roots have contact with. And then so with that, we can get the inches of water that can be held in the root zone, and then we keep track of the inches of water that's being used every day, and then that'll give us an idea of when we need to irrigate and how much we can apply. With that, if you refill the soil all the way to the top, that's field capacity. If you put more water on the soil than the field capacity, the water will go into the soil, but it'll keep on moving down past the bottom of the root zone, and it'll be lost to the crop and to the farmer, to the field. It's not lost. I mean, it keeps on moving down into the aquifer, but it's lost to the user. So field capacity is the most that soil can hold. And then permanent wilting point is where it's dry, where it's so dry that the crop is completely dead. So between field capacity and wilting point, and it's usually about halfway between those 2 points, there's what we call the management allowable depletion, or the maximum allowable deficit that we can allow, because you get maximum yields between field capacity. As when the soil is full, it's very easy for the plant to get that water away from the soil, and it grows with maximum, it's not water restricted at all. But then after a while, it starts drying out, and then you start the soil is holding on to that water a little tighter. The pathways for the water to move through the soil from the areas where it has water in the soil to the root hairs, where the water is being drawn up, get smaller and thinner, and so it has a hard time getting that water away. So field capacity is the maximum amount of water that we want to hold long term against the pull of gravity, and then MAD. So if we want maximum production, we want to be between field capacity and that maximum allowable depletion. So that's usually about half of the total water holding capacity. So with that knowledge, then we can estimate the amount of water that's withdrawn from the soil using weather data. So we take weather data and then we run it through some complicated models that do energy balance and stuff, and then we can calculate about how much water a reference crop of alfalfa would be using on that particular day. And then we multiply that by a crop coefficient that's specific to that particular crop and that particular crop's growth cycle, right? So it depends on when it's planted, when it's harvested, and when it matures throughout that season. So with those two things, the reference ET for alfalfa for that day, and then the crop coefficient for that day for that crop and that crop's growth stage, we can estimate how much water was used by that crop on that particular day. So reference ET is a function of weather, right? So alfalfa reference ET, and that changes a lot over the season. During the early part of the season, it's very small. During July and August, it gets very high, and then later in the season, it gets low again. And then you have that pattern that goes throughout the season, and then you have this day-to-day variation that changes just depending on the weather. And so if you have a string of hot days, you can get very high, ET, and then maybe it's overcast and it's cool, might be a little bit drizzling, and then those days are very small. So the ET is small on those days. So this takes that into account. And then crop coefficients, we can typically, of course, they're different for every crop and every season and everything, but we can estimate what those crop coefficients look like by 5 dates. The emergence date, the canopy exceeds this 10% of the field cover, and then when you get full cover of the rows, it kind of uses up all the available sunlight. The initial maturation, when it starts, it's done doing it with what it came to this world to do, which is produce seed, and then it starts drying down, and then the end of the growing season or harvest. So with those dates that most farmers can know just intuitively, and with these three numbers, these crop coefficient numbers, we can estimate how much water that crop coefficient curve. And so over the season, if time is on the x-axis, and then the inches of water in the soil on the y-axis, we can estimate how the soil water content will change over time. So here's field capacity. Here's that MAD point. Anywhere between field capacity and MAD, you're going to have a crop that grows fine. It's at maximum production. It's not water stressed at all. But as you decrease below that MAD point over time, you see increasing amounts of water stress until it's completely dead at wilting point. So if we want maximum production, we stay just in this top two lines over time. So we irrigate in order to push that soil water content back up. ET reduces the soil water content, we irrigate. So we can do this to do irrigation management. But so this is kind of complicated for most farmers to do, most homeowners. They're not going to go through the effort to calculate reference ET and know what the crop coefficient is, etc. So we put together this mobile app that does most of the work for you. It pulls the weather data from the weather station, calculates reference ET, multiplies by the crop coefficient. Because it's set up for your field, it knows what your soil water holding capacity is, and then it just gives you an idea. It does all that math and that balancing, the soil water balance for you. But we tried to make this very usable. In other words, if there was an accurate way to do it, but it required knowledge that most farmers don't have, like, let's say the soil's saturated hydraulic conductivity or some of these other things, then we just said we're not going to do that. And so we went for usability first. So this is an app that works throughout the West. It's connected to these weather stations, and we tried to make it simple and usable with kind of gas gauge, field capacity, permanent wilting point, MAD, and then so with the irrigation to put that back up. And so on your base screen, it shows you what this morning's soil water deficit is, and then if you irrigate today, you apply that water, and then it pushes that gas gauge back up, so you know when to irrigate and how much to apply. Again, so to set it up, all you need to do really, of course, you log in with your username and password, but if you click the Remember Me button, then you won't have to do that in the future. But you name the field, like the back 40, you choose the field year, 2021, you choose the network. In Washington State, it's WeatherNet. In Idaho, it's Agromet. You choose the station that's nearest you that represents your growing conditions, and then you choose your crop, and then you choose your soil. And with those just basic choices, we can set it up using defaults for our best estimates of what crop coefficients are, what your growing season is going to look like, what your soil's water holding capacity is, and then it populates and it sets that up for you, and then later on you can go into field settings and then change that to update that for your particular field. So the main screens are this daily budget table, which for that particular day, what the ET is. And then the main number is this soil water deficit, or how far down you are from full, or how much space you have in the soil. to add additional water, and that increases over time. When you get near that MAD point, it changes from green to yellow. When you go below MAD, it goes red. Again, we tried to make it very simple, and it does this graph for you. A lot of different screens that I won't talk about, a lot of different charts that you can show, crop coefficients, the daily crop water use. If you lose water to deep percolation, how and when that happens. If you have water stress, when was that water stress experienced by that crop and how much? It works for hay crops where you have periodic cuttings throughout the season. There's an option to reset or correct that crop coefficient for that cutting throughout the season. And then at the top of each of these screens is a help button that you can see that'll give you kind of a lot more information that's specific to that particular screen that you're on. So how do you find it? You just Google irrigation scheduler mobile or search for that wherever you find your apps that you use on your particular phone, like iPhone or Google Play Store or something. And then you can set that up and use it. So encourage everyone to play with that. When you do irrigation scheduling, you avoid over-irrigating, and especially in the springtime and in the fall, a lot of times you can leave the water off longer than you think you can, and this model will help you have confidence to do that and save the energy associated with good irrigation management, only irrigating when you actually need to.